Question 1. If the P term of an AP be Q and the Q term be the P, then its Rth term will be, we have four options: A, P plus Q plus R, B, P plus Q minus R, C, P plus R minus Q, and D, P minus Q minus R. Given that T of P is equal to A plus P minus 1 T, let this be equation number 1. T of Q is equal to A plus Q minus 1 D, which is equal to P. This can be written as equal to Q. Let this be equation number 2. From 1 and 2, we get D is equal to minus of P minus Q upon P minus Q, which is equal to minus 1. Putting the value of D in equation 1, we get A is equal to P plus Q minus a 1. Now the Rth term is given by AP, that is T of R is equal to A plus R minus 1 T, which is equal to, we can write A as P plus Q minus 1 plus of R minus 1 minus 1, which is equal to, we solve this, we get P plus Q minus R, which is our option B. Therefore option B is the correct answer. Question 2. If mth term of the series 63 plus 65 plus 67 plus 69 plus continue and 3 plus 10 plus 17 plus 24 plus continue be equal, then m is equal to, we have four options: A11, B12, C13 and D15. Given series, that is 63 plus 65 plus 67 plus 69, be first, 3 plus 10 plus 17 plus 24 plus be the second. So now from first, the mth term is equal to 2m plus of 61, and the mth term for the second equal to 7m minus of 4. So under condition, we see 7m minus 4 equal to 2m plus of 61. So we solve this, we get 5m is equal to 65, where m we get as 13, which is our option C. Therefore option C is the correct answer. Question 3. The ninth term of series 27 9 plus 5 2 by 5 plus 3 plus 6 by 7 plus will be, we have four options, that is 1 10 by 17, B 10 by 17, C 16 by 27 and D 17 by 27. Given series, that is 27 plus 9 plus 5 2 by 3 plus of 3 6 by 3, sorry 7. Please note that the series is 3 6 7 equal to, this will be 27 plus 27 by 3 plus 27 by 5 plus 27 by 7 plus this will be 27 by 2n minus of 1. So hence the nth term of given series can be written as Tn is equal to 27 2 into 9 minus 1. Solving this, we get as 27 by 17, which is equal to, we can write this as 1 10 by 17, which is our option A. Therefore option A is the correct answer. Question 4. If log to the base 3 2 log to the base 3 bracket 2 raised to x minus 5 and log to the base 3 bracket 2 raised to x minus 7 by 2 are in AP, then x is equal to, we have four options, that is 1 comma half, B 1 comma 1 by 3, C 1 comma 3 by 2 and D none of this. So we have AP given, that is log to the base 3 2 log to the base 3 2 raised to x minus of 5 and log to the base 3 2 raised to x minus 7 by 2, which are in AP. Solving this, we can write this as 2 log to the base 3 2 raised to x minus of 5 equal to log to the base 3 2 2 raised to x minus 7 by 2. Solving this further, we can write this as 2 raised to x minus of 5 the whole square equal to 2 raised to x plus 1 minus of 7. Solving this further, we get as 2 raised to 2x minus 12.2x plus 32 equal to 0. So we get as 2 raised to 2x minus 12 into 2 raised to x plus 32 equal to 0, which is, for the solving, we get x is equal to 2 comma 3. So but x is equal to does not hold, therefore hence x is equal to 3, which our option doesn't matches with the A, B and C. So D is the answer, that is none of this. So D is the correct answer. Question 5. The sum of n terms of two arithmetic series are in ratio 2n plus 3 is to 6n plus 5. Then the ratio of the 13th term is, we have four options, that is A 53 is to 155, B 27 is to 77, C 29 is to 83 and D 31 is to 89. We have S of n1 upon S of n2 equal to 2n plus of 3 upon 6n plus of 5. We gonna solve this. We're gonna use for sum of terms formula, that is n by 2 to a1 plus of n minus 1 d1 upon n by 2 to a2 n minus 1 to d2 equal to 2n plus of 3 upon 6n plus of 5. For the solving this, we take 2 common, we get 2a1 plus of n minus 1 upon 2 d1, 2 of a2 plus n minus 1 upon 2 t2, which is equal to 2n plus of 3 6n plus of 5. 2 get cancelled. We're left with a1 plus n minus 1 upon 2 d1, a2 plus n minus 1 upon 2 t2 equal to 2n plus 3 upon 6n plus 5. So we put n is equal to 25. We get a1 plus 12 of d1 upon a2 plus of 12 d2, which is equal to 2 of 25 plus of 3 upon 6 of 25 plus of 5. For the solving this in the term wise, we get this can be written as a1 plus of 12d as t of 13 1, and this can be written as t of 13 2, which is equal to, we get as 53 upon 155, which is our option A. Therefore option A is the correct answer. Question 6. Let T of R be the rth term of an AP for R is equal to 1, 2, 3. If for the same positive integer m, 1 we have T of m is equal to 1 by n and T of n is equal to 1 by m, then the T of mn equal to, we have four options, that is A 1 by mn, B 1 by m plus 1 by n, C 1 and D 0. For T of m, we have A plus m minus 1 of D, which is equal to 1 by n, and for T of n is equal to A plus n minus 1 into D, which is equal to 1 by m. On solving, we get A is equal to 1 upon mn and D is equal to 1 by mn. Substituting this value in T of mn, which is equal to A plus mn minus of 1 of D, 1 by mn plus of mn minus of 1 equal to 1 by mn. So in this further we get 1, which we see option C. Therefore option C is the correct answer. Question 7. If the sum of the series 2 plus 5 plus 8 plus 11 is 60100, that is, then the number of terms be, we have four options: A 100, B 200, C 150 and D 250. Series given, that is 2 plus 5 plus 8 plus 11, where we get A is equal to 2 and the difference, that is D, is equal to 3. Let number of terms be n. The sum of AP is given as n by 2, 2a plus n minus 1 of D. So you're going to substitute the values in this formula. We have sum of AP as 60100. So we're going to substitute this n by 2, 2 into 2 plus of n minus 1 of 3. Solving this further, we get 120,200 equal to 1 of 3n, n into 3n plus of 1. So we get 3n square plus n minus 120,200 equal to 0. Further solving this, we get n minus of 200 and 3n plus of 601 equal to 0. We take n 200 equal to 0, which is we get n is equal to 20, and we take n 3n plus of 601 equal to 0. We solve this, we get minus 601, n is equal to 601 upon 3. So we see for both the values, we get n is equal to 200, which is our option B. So therefore option B is the correct answer. Question 8. If the sum of the first n terms of an AP be equal to the sum of its first m terms, that is m is not equal to n, then sum of its first m plus n terms will be, you have four options, that is A0, B n, C m and D m plus n. Given condition, that is S of n is equal to S of m. So n by 2 2a plus n minus 1 of D is equal to m by 2 2a plus of m minus 1 into D. Solving this further, we get 2a m minus n plus D m square minus m minus n square plus of n equal to 0. We take m minus n, 2a plus of D, m plus n minus of 1 equal to 0. Further solving this, we get 2a plus m plus n minus 1 D equal to 0, where we know that m is not equal to n. So we get S of m plus n, we get m plus n by 2, 2a plus m plus n minus 1 of D. We see this, that is 2a plus m plus n minus 1 into D is equal to 0. So we're going to substitute this value, m plus n upon 2, 0. So multiplying this, we get 0, which is our option A. Therefore option A is the correct answer. Question 9. The interior angle of a polygon are in AP. If the smallest angle be 120 and common difference be 5, then the number of side is A8, B10, C9 and D6. Let the number of sides of polygon be n. Then the sum of interior angles of a polygon is given as 2 equal to 2 into n minus 4, that is pi by 2. We can write this as n minus 2 of pi. Since the angles are in AP, therefore we can take A is equal to 120 degree, which is given, that is the smallest angle, and D is equal to 5, that is a common difference. Therefore n by 2, 2 into 120 plus of n minus 1 of 5 equal to the angle which we have, the interior angle, that is n minus of 2 into 180, that is pi. So further solving this, we get n square minus of 25n plus 144 equal to 0. Taking the roots, we get n minus 9 and minus 16. We get n is equal to 9 and 16. So for n is equal to 16, the term 16 given as a plus 15d, where we substitute the value of a and d, we get 120 degree plus of 15.5 degree, that is 15 into 5 degree. Further solving this, we get 195, which is impossible as an interior angle cannot be greater than 180. So therefore 195 is not a correct answer for 16. So if we substitute 9, we get the value which is less than 180 degree, which satisfies the condition of interior angle of polygon. Therefore n is equal to 9 is a correct answer, that is option C is a correct answer. Question 10. If XYZ are in AP and tan inverse X, tan inverse Y and tan inverse Z are also in AP, then we have four options: A, X is equal to Y is equal to Z; B, X is equal to Y is equal to minus Z; C, X is equal to 1, Y is equal to 2 and Z is equal to 3; D, X is equal to 2, Y is equal to H and Z is equal to 6. So the given are in AP, that is 2 tan inverse can be written as 2 tan inverse of Y is equal to 2 tan inverse of X plus 2 tan inverse of Z. We can write 2 tan inverse of 2y upon 1 minus y square equal to 2 tan inverse of x plus z 1 minus x into z. Please note that we use that formula tan inverse of a plus tan inverse of b, which gives us a plus b upon 1 minus of a minus a into b. Therefore, further solving this, tan inverse get cancelled on both the sides. We left with 2y upon 1 minus y square equal to x plus z upon 1 minus xz. So we have, but 2y is equal to x plus z. We know that x, y, z are in AP. So we can write this as, which get cancelled, or which can be written as 1. So we left with 1 minus y square equal to 1 minus xz. Solving this further, we get y square is equal to xz. So therefore x, y, z are both in GP and in AP. Therefore we can say that x is equal to y, x is and y is equal to z. But this is in GP and this term is in AP. Therefore x is equal to y is equal to z, which is our option A. Therefore option A is the correct answer. Question 11. If the roots of the equation x cube minus 12x square plus 39x minus 28 is equal to 0 are in the AP, then the common difference will be. So four options, that is A plus minus 1, B plus minus 2, C plus minus 3 and D plus minus 4. Let A minus D, A and A plus D be the roots of the equation. equation of x cube minus of 12x square plus 39x minus 28 is equal to 0. Then you can write this as a minus d plus of a plus of a plus d equal to 12 and a minus d into a plus d equal to 28. Solving this both we get as 3a equal to 12, that is equal to 4. So in this equation we get as a into a square minus of d square equal to 28. So we substitute the value of a in this, we get 16 minus of d square equal to 7. So we get d is equal to plus minus of 3, which is our option C. Therefore option C is the correct answer. Question 12. If x, 2x plus 2, 3x plus 3 are in GP, then the fourth term is, we have four options, that is A 27, B minus 27, C 13.5 and D minus 13.5. Given that x, 2x plus 2, 3x plus 3 are in GP, therefore we can write this as 2x plus of 2 the whole square equal to x into 3x plus 3. Solving this further, we get x square plus 5x plus of 4 equal to 0. Factorizing it, we get x plus 4, x plus 1 equal to 0. So we get x is equal to minus 1 comma minus 4. So the first term p equal to x, that is a is equal to x, and the second term equal to a into r equal to 2x plus of 1. So we have r is equal to 2x plus 1 upon x. So the fourth term will be equal to, that is ar cube equal to will be x of 2x plus of 1 upon x the whole cube. For the solving this, we get 8 upon x square, x plus 1 the whole cube. So putting x is equal to minus 4. So for the fourth term we have t of 4 equal to 8 of 16 minus 3 the whole cube, which is equal to minus 27 by 2. Dividing this, we get minus 13.5, which is our option D. Therefore option D is the correct answer. Question 13. If every term of a GP with positive term is the sum of its two previous terms, then the common ratio of the series is, we have four options, that is A1, B 2 by root 5, C root 5 minus 1 by 2, and D root 5 plus 1 by 2. So let the first term and the common ratio of GP are respectively A and R. Then under condition T of n is equal to T of n minus 1 plus T of n minus 2. So we substitute the value, that is of the terms, that is A of r raised to n minus of 1 equal to A of r raised to n minus of 2 plus A of A into r raised to n minus of 3. Solving this further, making a fine adjustment in this, we get A equal to A of r n minus 1 r raised to minus 1 plus A of r n minus 1 r raised to minus 2. We get this as 1, taking common A of r n minus of 1, we left with A of r minus 1 plus A of r minus of 2. So A of r n minus of 1, this get cancelled, so we left with 1 equal to r raised to minus 1 plus r raised to minus 2, can be written as 1 upon r plus 1 upon r square. So solving this, we get r square minus of r minus of 1 equal to 0. We take root of this, we solve for r, which get r is equal to 1 plus of minus root 1 plus of 4 upon 2, which we get as 1 plus of root 5 upon 2. Taking only the positive one, where we see that r is greater than 1. So 1 plus root 5 upon 2 is the answer, which is our option D. Option D is the correct answer. Question 14. X is equal to 1 plus a square plus tends to infinity where a is less than 1. Y is equal to 1 plus b square tends to infinity where b is less than 1. Then the value of 1 plus ab plus a square plus b square plus tends to infinity is, we have four options, that is in x and y. Since the series in GP, therefore we can write x is equal to 1 upon 1 minus a and y is equal to 1 upon 1 minus b. We make adjustment, we get a is equal to x minus 1 upon x and b is equal to y minus of 1 upon y. So we have the sequence, that is series, that is 1 plus ab plus of a square b square plus, which tends to infinity, equal to 1 upon 1 minus of ab. So we substitute the value of a and b. So we get 1 upon 1 minus x minus 1 upon x into y minus 1 upon y. Further solving this, we get x into y upon x plus y minus of 1, which is our option A. Therefore, option A is the correct answer. Question 15. The sum of infinity terms of a GP is x, and on squaring the each term of it, the sum will be y. Then the common ratio of this series is, we have four options, that is in x and y. We have a upon 1 minus r equal to x, and squaring we get a square upon 1 minus r square equal to a into 1 minus r into a upon 1 plus r can be written, that is equal to y, which is equation 2. We can write this as equation 2 and we take this as equation 1. So we get y is equal to x into a upon 1 plus r, where we substitute a upon 1 minus r is equal to x over here. So further solving this, we get x 1 minus r upon 1 plus r into x. So if we further solve this, we get this as x square upon 1 minus r upon 1 plus of r. We take x square, on the left hand side we get y upon x square is equal to 1 minus r upon 1 plus of r. So we invert on both the sides, we get x square upon y, we get 1 plus of r, 1 minus of r. So further solving this, we take 1 minus r on the left hand side, we get x square upon y into 1 minus of r equal to 1 plus of r. Further solving this, we get r 1 plus x square upon y equal to minus 1 plus of x square upon y, which we further do adjustment, we get r equal to x square minus of y upon x square plus of y. So this is the final answer, which we get x square minus of y upon x square plus of y, which is our option C. Therefore, option C is the correct answer. Question 16. If the fifth term of HP, that is 2 comma 2 into 1 by 2, 3, 1 by 3 will be, we have four options, that is A 5 1 by 5, B 3 1 by 5, C 1 by 10 and D 10. So the series is 2 comma 2 of 1 by 2, 3 into 1 by 3 are in HP. So this can be written as 1 by 2, 2 by 5, 3 by 10, which will be in AP. So now for the first term, we have A is equal to half, and the common difference D is equal to 1 upon minus 1 upon 10. So the fifth term of an AP, that is D of 5, can be written as 1 by 2 plus of 5 minus 1 upon 1 minus of 10, which is equal to 1 by 10. So the fifth term in HP can be written as, that is 1 by 10, we get as 10, which is our option D. Therefore option D is the correct answer. Question 17. A fifth term of HP is 1 by 45 and the 11th term is 1 by 69. Then its 16th term will be, we have four options, that is A 1 by 89, B 1 by 85, C 1 by 80 and D 1 by 79. So the fifth term of the corresponding can be written as of AP A plus of 4D, which is equal to 45. That is of HP. For AP we get 45. So the 11th term of AP can be written as A plus of 10D, which we get as 69. Solving 1 and 2, we get A is equal to 29 and D is equal to 4. So for the 16th term of the corresponding AP can be written as A plus of 15D equal to 29 plus of 15 into 4, which is equal to 89. So hence the 16th term of HP is 1 by 89, which is our option A. Therefore option A is the correct answer. Question 18. If the arithmetic mean and the geometric mean of the roots of a quadratic equation are 8 and 5 respectively, then the quadratic equation will be, we have four options which is given in quadratic equation. So given that arithmetic mean is equal to 8 and the geometric mean is equal to 5. If alpha and beta are the roots of the quadratic equation, then the quadratic equation is x square minus of x alpha plus beta plus alpha into beta equal to 0. So for the arithmetic mean, we have alpha plus beta equal to 2 can be equal to 8. So we get alpha plus beta is equal to 16. And for the geometric mean, we have under root alpha and beta, which is equal to 5. So we get alpha into beta is equal to 25. So the required quadratic equation can be written as, that is, we substitute the value of alpha plus beta, alpha into beta in the equation. We get x square minus of 16x plus of 25 equal to 0, which is our option C. Therefore option C is the correct answer. Question 19. If A1 and A2 are the two arithmetic means between two numbers A and B, and G1 and G2 be the two geometric means between same two numbers, then A1 plus A2 upon G1 into G2 equal to, we have four options, that is A plus B upon AB, B A plus B upon 2AB, C 2AB upon A plus B, D AB upon A plus B. So given that A1 comma A2 and B are in AP, so then A1 can be written as A plus of A2 upon 2 and A2 A1 plus of B upon 2. So A1 plus of A2, we get half of A plus B plus of A1 plus of A2, and this can be written as half of A1 plus of A2 equal to half of A plus B, or can be written as A1 plus A2 equal to A plus B. And for GP we have A comma G1 comma G2 comma B are in GP. So solving this further, we get G1 the whole square of AG2 and G2 of whole square BG1. Let this be equation number 2. So solving this, we get G1 square to G2 square equal to AB G1 into G2, which can be written as G1 into G2 equal to AB, which we get as G1 into G2 is A into B. So hence we see that we take division of both, that is A1 plus A2 upon G1 upon G2, that is A1 plus A2 upon G1 upon G2 into G2 equal to, we have A plus B upon A into B, which is our option A. Therefore option A is the correct answer. Question 20. If the arithmetic mean is twice the geometric mean of the numbers A and B, then A is to B will be, we have four options. The given condition, that is arithmetic mean is equal to twice of geometric mean. That can be also written as half of AB, A plus B equal to 2 of root AB, or can be written as A plus B upon 2 of AB equal to 2 of 1. We solve this, we make fine adjustment, that is A plus of B plus of 2 of AB upon A plus of B minus of 2 of AB equal to 2 plus of 1 upon 2 minus of 1, which is equal to 3 upon 1. Solving this, we know that this can be given as root of A plus root of B the whole square upon root of A minus of root of B the whole square, which is equal to 3 upon 1. Taking square root on both the side, we get root of A plus root of B upon root of A minus of root of B, which is equal to root of 3 upon 1, which can be written this as A upon B equal to root 3 plus of 1 upon root 3 minus of 1 the whole square. But this can be further solved as A upon B equal to 2 plus of root 3 upon 2 of minus root 3, where we get A is to B is equal to 2 of plus root 3 is to 2 of minus root 3, which is our option B. Therefore option B is the correct answer. Question 21. If the ratios of harmonic mean and the geometric mean between two numbers A and B is 4:5, then the ratio of the two numbers will be, we have four options: A 1:2, B 1:4, C 4:1, and D B and C. So we have arithmetic mean as 2AB upon A plus B and geometric mean as equal to root of AB. So we take both the ratio of this, that is harmonic mean upon geometric mean, which is equal to 4 upon 5. So we substitute the value of harmonic mean and geometric mean, so we get as 2AB of A plus B upon root of A to B equal to 4 upon 5. We further solve this, we get as 2 of root AB upon A plus B, which is equal to 4 upon 5. So we can write this as A plus of B, A plus B 2 into root of AB equal to 5 upon 4. We see that we do inverted on both the sides, so we make a fine adjustment, that is A plus of B plus of 2 root of AB upon A plus of B minus 2 root of AB, which is equal to 5 plus of 4 upon 5 minus of 4. So further solving this, we can write this, we know this is A plus B the whole square, so we can write this as root of A plus root of B the whole square upon root of A minus of root of B the whole square equal to 9 upon 1. So taking square root on both the side, we get root of A plus root of B upon root of A minus of root of B equal to 3 by 1. Further we solve, we can write this as root of a plus root of b plus of root of a minus of root of b, that is we do rationalism with the conjugate of denominator equal to 3 plus of 1 or 3 minus of 1. We see we do over here, we solve this further, we get 2 root of a upon 2 root of b equal to 4 upon 2. Further solving this, we get root of a upon root of b equal to 4 upon 2. Taking square on both the side, we get a upon b is equal to 16 upon 4, which is, we cancel out, we left with 4. We can write it this as 2 square also. So therefore, so we left with a is to b, that is equal to 4 is to 1, which is our option. We can also write it this as b is to of a, that is 1 is to of 4. So we compare this option. So we compare this option, that is a is to b and b is to a, that is b and c. So the option D, which contains b and c, is a correct answer. Question 22. If the altitudes of triangle are in AP, then sides of triangle are in, we have four options, that is AAP, PHP and CGP and D AGP. So let P1, P2, P3 be the altitudes from PQR. If we draw a triangle, altitudes from all the angles, making an angle of 90. Let P, Q, R. Let PR be the side P. Let QR be equal to A and PQ be C. Let this be P1, this be P2, let this be P3. So let P1, P2, P3 are the altitudes of PQR. So for P1, we can write this as C of sine Q is equal to lambda of BC. For P2, we can write this as A of sine R, lambda of CA. P3 as B sine of P equal to lambda of AB. Since we have sine P upon A is equal to sine Q upon P equal to sine R upon C, which is equal to lambda. So therefore we can say that P1, P2, P3 are in AP. We also can say that lambda PC, lambda CA, lambda AB are in AP. So we can write this as BC, CA, AB are in AP. So we can write this as ABC upon A, ABC upon B, ABC upon C, which are also in AP. So 1 upon A, 1 upon B and 1 upon C are in AP. We can just write it as 1 upon A, 1 upon B, 1 upon C are in AP. So the thing we can say that we conclude that A, B, C are in HP. That is, the size of triangles are also in HP. That is A, B and C are in HP. That is our option B. Therefore option B is a correct answer. Question 23. A boy goes to school from his home at a speed of X km per hour and comes back at a speed of Y km per hour. The average speed is given by, we have four options: A, arithmetic mean, B, geometric mean, C, harmonic mean, and D, none of this. So let the distance of the school from home be equal to D, which is the distance of school from home, and time taken are T1 and t2. So let t1 is equal to d by x and t2 is equal to d by y. We have the formula for average velocity is equal to, that is total distance upon total time. We can substitute the value, that is 2d upon t upon x plus d upon y equal to, solving this we get 2xy upon x plus y, which is the harmonic mean of the x and y. So we conclude that option C, that is harmonic mean, is a correct answer. Question 24. The sum of series 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus tends to n terms is, we have four options, that is in n. So we have term tn as 1, n plus 1 and n plus of 2, which can be further solved as n of n square plus of 3n plus of 2. We multiply n in the bracket, we get n cube plus of 3n square plus of 2n. The sum of Sn can be written as summation of n cube plus summation of 2n, which can be written as n into n plus of 1 upon 2 the whole square plus 3 of n into n plus 1 into 2n plus of 1 upon 6 plus of 2 into n plus 1 upon 2. Further solving this we get as Sn of 1 by 4 n into n plus of 1, n plus of 2, n plus of 3, which we get as our option C. Therefore option C is a correct answer, that is 1 by 4 into n into 1 plus 1 into 1 plus 2 into 1 plus 3. Therefore option C is the correct answer. Question 25. 2 plus 4 plus 7 plus 11 plus 16 plus tends to infinity terms is equal to, we have four options, that is a 1 by 6 n square plus 3n plus 8, b 1 n by 6 n square plus 3n plus 8, c 1 by 6 n square minus 3n plus 8, d n by 6 n square minus 3n plus 8. We have s is equal to 2 plus 4 plus of 7 plus of 11 plus of 6, which tends to term tn, and again we can write this as 2 plus 4 plus of 7 plus of 11 plus tends to tn, t of n minus 1 plus t of n. So subtracting both we get 0 is equal to 2 plus bracket 2 plus of 3 plus of 4 plus of 5 continues to t of n minus of tn minus of 1 bracket of t of n. T of n can be written as 2 plus half of n minus 1 bracket 4 plus n minus 2 bracket. So for the solving this we get half n square plus of n plus of 2. So now S is equal to summation of tn, that is summation of term, we get as half of summation n square plus of n plus of 2. For the solving this we take summation inside the bracket, we get half of summation of n square plus summation of n, 2 of summation of 1. So we can solve this as half of 1 by 6 n of n plus of 1 and 2n plus of 1 plus of half n plus of 1 plus of 2n. For the solving this we get n by 12 n plus of 1, 2n plus of 1 plus of 3 plus of 12. For the solving this, we can write this as n by 6, n plus of 1, n plus of 2 plus of 6. So we solve this bracket, we get n by 6 n square plus of 3n plus of 8, which is our option B. Therefore option B is the correct answer. Question 26. Sum of n terms of series 12 plus 16 plus 24 plus 40 plus will be, we have 4 options given in n. Let n of the series is Tn, then S of n can be 12 plus 16 plus of 24 plus of 40 plus of Tn. So again we can write this as Sn of 12 plus of 16 plus of 24 plus of Tn. Subtracting both, we get 0 is equal to 12 plus of 4 plus of 8 plus of 16, which tends to plus of up to n terms, that is minus of Tn. So we can write this as Tn is equal to 12 plus of 4 plus of 8 plus of 16 plus tends to up to n minus 1 terms. For the solving this, we get as 12 plus of 4 2 raised to n minus of 1 upon 2 minus 1, which we get this as 2 raised to n plus 1 of plus 8. On putting n is equal to 1 comma 2 comma 3, we get this as T1 is equal to 2 square plus of 8 42, we get as 2 cube plus of 8 43, we get as 2 plus 2 raised to 4 plus 8, and etc. So for Sn, that is sum S of n Tn plus of T2 plus of T3, that is plus of Tn. Substituting the value of T1, T2, T3, we get as 2 raised 2 square plus 2 cube plus 2 raised to 4 plus up to n terms, plus 8 plus 8 plus of 8 up to n terms. Further solving this, we can write this as 2 square 2 raised to n minus of 1 upon 2 minus 1 plus 8 of n. This part is of 2 square 2 cube and 2 raised to 4 plus up to n terms, and 8n is of this term. So further we can write this as 4 into 2 raised to n minus of 1 plus of 8n. So this is the final answer, that is 4 into bracket 2 raised to n minus of 1 bracket plus 8n, which is our option matches with D. So option D is the correct answer. Question 27. The sum of few terms of any ratios series is 728. If common ratio is 3 and the last term is 486, then first term of series will be, we have 4 options, A2, P1, C3 and D 4th. And term of series is equal to A into R raised to n minus 1, which can be substitute the value of R, that is common ratio, as 3 n minus 1, which is equal to 486. So the sum of n terms of series can be written as n S of n A into 3 raised to n minus of 1 upon 3 minus 1 equal to 728. Since we know that R should be greater than 1, so let this be equation 1, let this be 2. So from 1 we can write this as a into 3 raised to n upon 3 equal to 486, which is a into 3 raised to n 3 into 486. So from 2 we have a into 3 raised to n minus of a is equal to 728 into 2. We can write this as a into 3 raised to n minus of a is equal to 1456. So we substitute the value of a into 3n, that is 1458, minus of a 1456. For the solving this, we get a is equal to 2. Therefore, our option A matches with the answer. Therefore, option A is the correct answer. Question 28. X plus y plus z is equal to 15 if 9 x, y, z, a are in AP, while 1 upon x plus 1 upon y plus 1 upon 2 is equal to 5 by 3. If 9, x, y, z, a are in HP, then the value of a will be, we have four options, A 1, B 2, C 3 and D 9. So we have x plus y plus z is equal to 15 if 9, x, y, z, a are in AP. So the sum of this will be 9 plus 15 plus of a, that is equal to 5 by 2, 9 plus of a. We further solve this, we get as 24 plus of a equal to 5 by 2, 9 plus of a, which is equal to 48 plus of 2a equal to 45 plus of 5a. We solve for a, we get 3a is equal to 3, which is a is equal to 1. So we, for second, we have 1 upon x upon 1 upon y plus 1 upon z is equal to 5 by 3. If 9, x, y, z, a are in HP, the sum of this can be given as 1 by 9 plus 5 by 3 plus 1 by a, which is equal to 5 by 2 bracket of 1 by 9 plus 1 by a, which is, we solve this, we get a is equal to 1. Therefore, for both the things, we get a is equal to 1. Therefore, our option A, that is 1, is the correct answer. Question 29. The 99th term of the series, which we have 2 plus 7 plus 14 plus 23 plus 34 plus is, we have four options. So let S is equal to 2 plus 7 plus of 14 plus of 23 plus of 34 plus, which tends to terms Tn. Let be equation 1. And S is equal to 2 plus 7 plus of 14 plus of T of n minus 1 plus of Tn be 2. So from 1 and 2, we can write this as, we subtract both, we get 0 is equal to 2 plus 5 plus 7 plus 9 plus 11 plus of T of n minus T of n minus 1 minus of Tn. Further solving this, we get Tn is equal to 2 plus n minus 1 upon 2 bracket 2 into 5 plus n minus 2 of 2. For the solving this, we get T of n is equal to 2 plus n minus 1 into n minus n plus 3. We put n is equal to 99, which we need to be find, that is 99th term. So we get T of 99 equal to 2 plus 98 into 102, which is equal to 9998. When we multiply, we solve this, we get 9998. So which is our option A. Therefore, option A is the correct answer. Question 30. The sum of series 1 into 3 the whole square plus t into 5 square plus 3 into 7 square plus up to 20 terms is, we have four options. Hence, for the first factor, that is Tn of the AP 1, 2, 3, that is equal to n times 7. And over the second factor of the AP is 3, 5 and 7. is equal to 2n plus 1. As we see, it is a square, so the term we get as 2n plus 1. So Tn given series can be written as n into 2n the whole square, that is equal to 4n cube plus 4n square plus of n. Taking the sum, that is the summation of 1 to 20 of t of n, that is the substituting the value of tn, that we get as summation of 1 to 20 4n cube plus 4n square plus n. Solving this, we take summation inside the bracket, we get 4 summation of 1 to 20 n cube plus 4 summation of 1 to 20 n square plus summation 1 to 20 n. For the solving this, we get as 4 into 1 by 4 20 the whole square into 21 the whole square plus 4 1 by 6 20 into 21 into 41 plus 1 by 2 20 into 21. Solving this and calculating, we get 188090, which is our option A. Therefore option A is a correct answer.